So today I'll be talking about how we'll be using or compiling programs on our direct HPS or the ARM processor that we have on the D1 terasic board. So as we know, our D1 terasic board has ARM Cortex M9, so we can directly run our programs through there through our HPS. So the idea is to run the HPS, and we'll see how this HPS would interact with our board peripherals. So that's what we are trying to do. We are using the HPS to control the FPGA board peripherals. So we have written a simple program here that is to blink the LED on our FPGA peripherals. So yeah, this basically before this, so let me talk about some of the software that we need. uh, on the first hand, we need the Intel SoC EDS embedded development suite. So in that, we will basically get the embedded shell and all the header files that you need. These header files basically contain all the addresses information, like the offset information that you need to address the peripherals, so that your HPS can address the peripherals. And then I'm using Cygwin because Cygwin is basically a emulator which lets you use Linux over within your Windows. And then I'm using Linaro. Linaro is basically the ARM cross compiler, and this is used by SoCEDS basically within the embedded shell in order to create. It's a GC compiler which basically compiles it so that the compiled program is processable by our HPS that is there on our board. So yeah, these are the three things that I'll be using, and yeah, here goes the program. Now we have the header files. As I was saying, the header files basically contains the information that the HPS would need in order to address the peripherals. So yeah, in that sense, this is the base address for our GPIOs, and that is being put in here. We are defining it basically, and we have already defined some of the libraries that we need and the header files that we need. And this is just showing how much of that block do we need to map. And is this just makes sure that within that 64 whatever space that we are creating here, within that we have the GPIO registers so that we can control our LEDs. So yeah, we are making sure that within the 64 KB space, we have our registers to address the LEDs. Now this is the direction. Now this is how we address that one LED bit that is there on our board. So that is what these two are. And this button mask is basically to check when the user presses the button what goes on, or that's what you need to when you need to address the user button on our peripheral. That's what we use. And that's for this. And then we have the virtual base. This will be the pointer address, which I'll be talking about later. And this is for dev map, and this is to store the scanned input, and this is for our loop. Now what we are doing here is, now we are telling the thing is, our HPS doesn't know what a peripheral is and what they are. So what we are trying to do is, we are creating these peripherals have basically, like, if you think, like, they have the registers at the back end, and we are basically mapping these register ports as memory to our HPS. So our HPS will be addressing these peripherals as memory. So yeah, to do that, what we're doing is we're trying to map the peripherals to the memory. So our HPS will basically have this whole memory within which it has this, specified zones, you could say it, for each of the peripherals. So yeah, now what we're trying to do is we are trying to address that and get that into our program, which we are saying it here. And then this will be our virtual pointer. This will be our pointer. This is used to address the original space within this program. So yeah, that's what mmap does. This basically maps the original address to this pointer here, so that we can use it within our program. That's what we are doing. It's asking to read and write permission, and we could read and write there, and all the changes would be affecting the main memory and so on. So yeah, this is basically where we are mapping the original address to our pointers here, so that our HPS can address the peripherals. Now here, if we come down here, now we are going, this is just to set the bits and just test it out, you know. This is just for first, we are using the sanity bits. This is used to set bit, and this virtual base plus this will basically be the address where we want to, you know, communicate with that specific register. And then we are using mask, and we are sending the data what we want to do. Since we are trying to set it, what we are doing here is we are running a for loop for 2 times so that the LED blinks twice when it turns on. This is like a sanity check that we are doing. And then for the second half of the program, we have written a forever loop. So like a while loop that doesn't terminate, in which it basically scans if the user button is pressing the button, and then if they are pressing the button, then the LED basically turns on. So that is the idea with this program. The main idea comes here where we are using the concept of addressing the peripherals as memory mapped slave ports. So yeah, that's how it goes. This is the main idea here. Now I'll be showing how we would go about executing this. So let me go to the command shell and compile the program. So you would find this in your C drive. After this, here you'll find your embedded shell where you'll be using, to compile your program. Now within here, first I'll be getting where my address is, or more specifically where my file is. Let's go ahead and minimize this. Now if we go within this folder, we have the files here. This make file will create the executable file. This is basically for it auto runs the whole process of compiling the program. So what I'm going to do is, if I run the command make, it doesn't show anything here because I've already built it and I have the HPS GPIO file here. Now this is the file that is generated through that, and let us see. So these are some of the files. This is the one of the file that will be generated, and this is the other executable file that will be generated because of using Linaro, that addresses a ARM cross compiler. So yeah, using that we have generated this file. This will now be our executable file which will be running on our HPS. Now let me just jump ahead and show how I will be dumping this. So here now I've booted the Linux terminal on my through my FPGA. So what I've done is I've used a micro SD card here, for which I've burned Linux onto this micro SD card, and I'm running it here. And this will be the pen drive with which I have shared I've added the file that was created. And yeah, now let me go ahead and root this. Once it's done, let us read all the files. As you can see, all the files are read, and you can see here this is where our file is sitting basically, and these are the other spaces that are there within the USB drive. Now let's go ahead and read this. So now the USB that I connected is now mounted, and then let's go into the folder here, and then once we have our program HPS GPIO. Now I'll be running this program. Now as I run this, as you can see, the LED blinked twice, and then every time I press the button, our LED turns on. So that is the program. Thank you.